Not a self-portrait on your shirt.
All right, so I finished my general announcements. Highlights are 3 things are due next week on Monday: homework 29, homework 30, and the review packet for this unit test. Retakes for CFUs 7 and 8, 10 are extended to beyond the Thanksgiving break. I recommend that students don't stress about trying to get those retakes in right now or even Monday, Tuesday next week, although you can if you want to. You'll have time to come back to Thanksgiving break to retake those. Okay, today is our second day of review. So once again, you have this list of topics that these are the items that you need to be able to do. And we're going to practice all of this today in class. So the bottom line is, yes, you have a review packet. You can check the FP on campus yourselves. But if you can do what's in that review packet and you can do what we're doing in class today, you should be able to do just fine on the test. Right? Now, as I already told you all, a lot of today is going to be, you have time to work ahead of you. So that's what I'm going to do here. Number 1 says identify the characteristics of the graph f of x equals e to the x. Use proper notation. Let me be clear, you don't have to type this into a calculator. It's already graphed for you. So this is me just giving you an opportunity to see, can you list the features of a graph or not? You got 2 minutes. Go. Keep going. Let me just kind of repeat the last thing I said. It would be bad to say 1, 0. That is a completely different point. So if you say 1, 0, you're not getting full credit. Okay. Kendry, can you tell me the asymptote? Oh, it is 0, but is it y equals 0 or x equals 0? No.
Y equals 0 or x?
It's y equals 0. So don't just tell me 0, tell me y equals 0. That, by the way, is this horizontal line. Okay, that is the line y equals 0. By the way, remember, all horizontal asymptotes, the reason we say y equals a number is because right here it hits the y-axis at 4. Here it hits the y-axis at 2. Here it's hitting the y-axis at -3. Here it's hitting the y-axis at 0. All horizontal lines are y equals a number. If you make the mistake, so it would be bad to say x equals 0. Well, then you're talking about this line. Does that make sense?
Okay.
All right. Questions before we turn the page. So this is one of the things I'm going to test on Monday. Can you name the properties of an exponential graph? Next thing. Identify the following functions as growth or decay. Provide a written explanation for your answers. I don't need a long written explanation. When I look at this, I realize, oh, the base isn't 7, it's a negative exponent. So actually, the base is 1/7. And because that's less than 1, it's decay. Same thing with the next one. It's not just 1/3, it's got a negative exponent, which means it's really 3, which is greater than 1. So it's a growth function. The third one does not have a negative exponent. So you can just use the base just as it is. The base is 5. That's a number bigger than 1. This is growth. Okay? So your written explanation can literally just be you comparing the base to the value 1. If it's less than 1, it's decay. If it's greater than 1, then it's growth. And pay attention to whether or not the exponent is negative. Because that means you need to flip the number. Okay? Questions on those 3? Yes, ma'am. So the question was, what about just plugging into a calculator? You absolutely can do that. For example, let me kind of demonstrate the last one real quick. If you want to type 3 to the negative 4x, okay? So y equals 3 raised to the negative 4x. What you're going to see is you might think because the base is 3, which is bigger than 1, it's growth. But when you hit graph, you're going to see that it's decay. Now, the other thing is, I know that a lot of folks are not really comfortable plugging in negative exponents. So if you wanted to, you could flip the 3 yourself and then type it without the negative exponent. Those two functions are exactly the same function. Okay, so if I hit graph, you won't even see the blue one anymore because the red one's going to trace right on top of it. Okay? Other question. So this is the second thing I'm going to test. Okay, I'm going to test, can you recognize whether or not a function is exponential growth or is it exponential decay? All right, now we're going to get to interest. And we tacked on this idea of continuous interest. So we have two different formulas. Now I want to be clear, I'm not expecting you all to have these formulas memorized. They will be given to you on the test. The question is, do you know when and how to use them? Okay. So as I said, I got a couple comments here, and then I'll give you time on the work at the bottom. It says Maya plans to deposit $1,000 into a bank account. That is my initial value. And leave it in the bank to gather interest for 5 years. That is my time. She researches the interest rates at two banks. Her findings are in the table below. So we've got the Mizrahi Bank that offers 5%, and it compounds weekly. I'll come back to that weekly thing in a moment. Here we've got an interest rate of 4.6%, and it's compounded continuously. I'll come back to the continuously in a moment. The side comment I want to make is, remember, you have to convert the percentages. Percent literally means per 100. So you have to take the number 5 and divide it by 100. So you're converting it to a per 100 number. Okay? Or a 100th number. Same thing over here. 4.6 divided by 100 is 0.046. So that is the value you're using for R here, for the Oben and Lee Bank. This is the number you're using for the Mizrahi Bank. Now, when we talk about compounded monthly or weekly or yearly, those are the three I'm expecting you all to have memorized. If I tell you compounded annually, I will remind you that's once a year. If I say compounded semi-annually, I will remind you that's twice a year. If it's compounded quarterly, I will remind you that's 4 times a year. But the other three, I expect people to have memorized. I'm going to put a couple folks on the spot here. Oscar, how many months are in a year? 12. Brian, how many weeks are in a year? 52. And let's see, Chris, how many days are in a year? Perfect, 365. So those are the three numbers I expect you all to have memorized. So when you're told compounded weekly, they're telling you that this N number is equal to 52. Okay, now over here, they say compounded continuously. When you read that word, you want to think, oh, that's the one with the E. That's that other funky formula that we learned. Okay, so the bottom line is we've got to help Maya decide which bank should we go with. Obviously, 5% is a better interest rate, but continuous interest is better than weekly interest. So the question becomes, which of these is actually offering the better people? Okay, so that's what I'm going to leave up to you all. For the first one, you have to be using this formula. For the second one, you have to use this formula, because the first is compounded weekly, the second is compounded continuously. What I'm going to do is give you all 4 minutes. The one thing I will show, and I'm not going to show this for both of them, I'll just show for the first one. I'm giving you the value you should end up with. That way you'll know if you're doing this correctly or not. Okay, so take 4 minutes. Try to complete those 3 problems. Do B, do C, and then compare them to tell Maya which bank should you go with. Okay, go. All right, so I gave you all the 4 minutes. If anyone wants me to show how to type this into a calculator, just say so. But with this first example, you start at $1,000. You are gaining 5% interest, which is cut into weekly payments. Okay, which means you are going to get 52 payments each year, and this is going to happen for 5 years. Now, with the other situation, the formula I would argue is a lot easier to use. I mean, it has the E, which is a little annoying, but you start at $1,000. It's continuous, so you use E as the base, and then you just raise it to the interest rate times the time. Okay, so the first bank offers a slightly better interest rate than the second bank, but the second bank is offering continuous interest. If you look at the 2 values, you'll see in the end, it's actually better to accept the first bank's deal. Their interest rate is high enough that it is more powerful than the lack of compounding. Okay, so I said for the question, which bank should Maya choose? I said the Mizrahi Bank. My justification is that 1283.87 is greater than 1258.60. Question. All right, so we've now looked at an example of compound interest and continuous interest. But here's the thing, in these problems, you were given the rate. You were told 5%. You were told 4.6%. I warned you all before that this problem that's on page 44, this is the one problem I'm going to go through myself. This was the problem that the students told me last year was the hardest for them. Because in this problem, you don't know the rate. You aren't told. Okay? So our goal, let me just kind of paint the picture here. They're going to give us some information, ask us to find the rate. That will allow us to set up the actual equation. Okay, so we will be able to set up the equation after we figure out the rate. And then we'll use the equation to make another prediction. That's kind of the flow of the question. Okay, so again, I'm going to walk you through this one and then I'll give you time on the next page, which is just another example of that exact same type of problem. Okay, here we go. In 1995, there were approximately 54 million mass transit users in the United States. In 2000, okay, I'm going to stop right there. I've now noticed they're talking about a time span of 5 years. Okay, that's something I'm connecting. In 2000, the number of mass transit users grew to 90 million. So here's kind of my takeaway from that sentence. We started at 54 million. 5 years later, we hit 90 million. That's the information I'm going to use. Okay. It says find the rate of change R that represents the rate of increase for the number of mass transit users. Note the value of R should be correct to 3 decimals after the decimal point. So notice they tell us you start at 54 million. They tell us that 5 years later, okay, 5 years later, so that's going to be a 5, we end up with 90 million users. What they did not give us was R. So we have to set up this equation with the information we know to actually solve for R. Okay? So I would argue the hardest part about this question is, can you read this and write that? That to me is what makes this question so challenging. Now, I'm going to, just for a moment, I'm going to do something in the calculator that I don't want you all to do. Okay? So just for the next minute, just put your pencils down and kind of pay attention. Just watch and listen. Which one's two? Okay, the whole idea here is we start at 54 million. We're growing by some rate that I don't know. And 5 years later, we hit 90 million. Okay? Here's what I don't want you to do. I don't want you to guess. Like, oh, maybe the rate is 7%. Does that get you to 90 million? No, that's not enough. All right. Let me jump to 9%. Is that enough to get me to 90 million? No. All right. Let me jump higher to, let's try 12%. That enough to get to 90 million? Okay, that's too much. So I went too high. Let me drop to 11%. All right. Is that going to get me to 90 million? Oh, that got me past 90 million. So that's that's too much. Let me try 10%. Oh, and you all can't see it, so let me do it this way. Let me try 10%. All right, that's too little. Okay, so I'm messing around and I'm figuring out the rate has to be somewhere between 10 and 11%. See what I'm talking about? I don't want you to do this. This is against the idea of setting up an equation and solving. Brian, you good? All right, make sure you're watching, sir. So I'm going to solve this equation because I don't know what the rate is. All I know is that if I start at 54 million, then 5 years later, I'm supposed to be at 90. Now, hopefully you all can help me out with this. What would you recommend as a first step? Take away the 54. Someone other than Chris tell me, how do we get rid of the 54? I'm not going to subtract. It doesn't say plus 54. Divide. Then divide by 54. So I'm going to divide both sides by 54. Now on the right side, the 54 is just going to go away. Because 54 divided by 54 is 1. And so all you're left with is 1 times the stuff. But on the other side, we're going to get kind of an annoying decimal. 90 divided by 54. I'm always going to round to 3 decimals. I'm gonna call that 1.666, but I'm gonna round that to a 7 since the next number is a 5 or higher. Okay, so when I divide both sides by 54, I get here. Oh, shoot, I accidentally revealed a little bit of the next step. Hopefully people didn't see that. Okay, I'm trying to solve for R. Can anyone remind me, how do you get rid of the fifth power? The fifth root. We have to remember that powers and roots are opposite. So if you want to get rid of the fifth power, you have to take the fifth root. Now on the right side, the fifth root and the fifth power just go away. So on the right side, you're just going to have 1 plus R. But on the left side, I need my calculator for that. So let me remind you how to do this in your calculator. If you want the fifth root, type 5. Then press the math key and go down to the variable root symbol. Since I already typed a 5, the calculator will know I want the fifth root. And then I just type 1.667. Now again, I go to 30 decimals, so I'm going to call that 1.0107, but notice the 7 has a 6 after it. So I'm going to round that 7 up to an 8. Okay, so when I take the fifth root, that gets me here. Still not done. R is not by itself. What do I still need to do? I need to subtract. What do I need to subtract? Am I 1? I'm going to subtract 1 from both sides. That gets me R is equal to 0.108. Now, let me just rewind the clock for just a moment. When this problem started, I showed you all a guessing game process that I don't want you doing. So let me remind you of that, how that sort of guessing game ended. What I said was, we started at 54 million. We're going up by some number. I don't know what it is. I guessed it might be 10%. But the problem was that did not get me to 90 million. That wasn't good enough. And then I said, all right, well, it's got to be a little bit higher. Let's try 11%. Oh, that's too high. That's almost 91 million. So then what we're realizing is we just found that if you use a percentage of 10.8, we use 0.108. That's what we saw. That gets you pretty much right at 90 million. I mean, granted, it would round, but you see what I'm saying. Okay. So now we know when we write an exponential model, we know we started at 54 million. We just solved for the rate is 0.108. So plug those numbers in and you've got your equation. The part B says write an exponential model in this form that represents y equals the number of mass transit users in the United States. And T is the number of years since 1995. Because that's when this all started. So back in 1995, it was like 4 million. 5 years later, it's at 90 million. That's all I need. I don't need you to do anything else. Just show me the formula you would use. Now, part C comes along and says, okay, well, let's actually do something with this. Okay. So C says, use your model. So I'm going to use this model that we just wrote out to determine how many million mass transit users were in the United States in the year 2015. Okay. Anyone have any idea what we're supposed to use for time here? So 5 is what we use in the original problem, because the original problem said, let's start at 1995 and go all the way to 2000. That was 5 years later. But now, granted, we have an equation that starts at 1995. I'm trying to make a prediction in the year 2015. Jazz? What is it? 20. We have an equation that started in 1995. We're now trying to make a prediction as 2015. So our time is going to be that 20-year gap. Does that make sense? So I'm just going to take my formula from part B, and all I'm going to do is plug in 20 for T. That's literally all I have to do. So I start at 54 million. We're going up by 0.108 for 20 years. And if you plug this in, we're going to get a prediction for how many millions of mass transit users are in the United States. We have 419.942 million. So I gave students 5 minutes to work ahead of me on this page. I've still got another minute and a half. I'm going to reveal part of my thought process. This is just my first 2 steps in solving this problem. Okay, you were told you started with 90 million Instagram users, and 5 years later, there were 960 million. Right, so I briefly already pointed out, the way you've set up this equation is understanding you started at 90 million, 5 years later, you hit 960 million. Okay? Folks, we shouldn't be packing up. We got 4 minutes. I'm only going to use 2 of those. Please slow it down a bit. Here, I'm going to take the fifth root of both sides. That gets you a decimal, which you would subtract 1 from, and that gets you the rate. So I now know that if the number of Instagram users grew from 90 million to 960 million in only 5 years, that means the average rate of growth was about 60.5% each year. That, by the way, is an insane amount of growth. Okay? Now, that allows me to set up the following formulas. Because all I needed to know was 2 numbers. What did I start with? What's my growth rate? If you just know those 2 numbers, you can set up these basic growth and decay functions. What did you start at? What's your growth rate? Done. Now, with the last question, it's saying use the model that you just found. So I'm going to copy my work from part B here. It has to occur to me that I have data that started in 2013, and they're asking me to make a prediction in 2020. So that is a 7-year span. So that has to occur to you. I started in 2013, I'm trying to make a prediction in 2020, that's 7 years later. So I'm going to use my formula from before, but I'm going to plug in 7 for the time. And this is what allows me to predict the number of Instagram users in the year 2020. And in case you're curious, 2,400 million is the same as 2.4 billion, which is kind of crazy. But like I said, a growth rate of 60% every year is really, really rapid growth. All right, we are done. Bell's gonna ring in about 2 minutes. Once again, on Monday, you're walking with over 29, 30, and the review packet. If you're not able to finish the test Monday, you will have time Tuesday to finish it. I suspect some of you will finish it on Monday, though. Okay? Anyone wants to recording? Thanks for watching. Have a good one.